Thank you for joining me today as we talk about implementing text-to-speech using AWS Lambda and Amazon Polly. Amazon Polly uses deep learning technologies to synthesize natural-sounding human speech so you can convert text to speech. With dozens of like voices across a broad set of languages, you can use Amazon Polly to build speech-activated applications. Amazon Polly supports speech synthesis markup language, also known as SSML. In this AWS tutorial, we will create a Lambda function that integrates with Amazon Polly to convert a simple text file into an MP3 audio file, which we store in Amazon S3. Okay, let's get started. Have some fun. So let's start with a quick overview of what we're going to cover in this AWS tutorial. The first thing we'll look at is just creating the AWS Lambda function that integrates with Amazon Polly. The next thing we'll do is actually run it and generate audio. The third thing we'll do is look at the various audio options available to you with Amazon Polly. Next, we'll look at how Amazon Polly supports SSML. And finally, we'll close out with some best practices. Okay, so let's go over to the AWS Lambda homepage to create a function. I'm going to go pretty quickly through this, but if you want to go through it in more detail, I've created a previous video on creating a basic Lambda function, so you can look at that to go through to see this a little bit more slowly. But for now, let's go ahead and click Create Function. We're going to author from scratch. I'm going to give it a name, select Python 3.8 as my runtime preference. I'll use all the other defaults and then click Create Function. So before we go ahead and write any Python code, I'm going to go over to the role associated with this Lambda function. Again, I'm going very quickly through this. I have a second video that I've created on AWS Lambda with roles that you can look at to see this more slowly. But I'm going to attach some policies that give me permissions to integrate with Amazon Polly and Amazon S3. So what this does is these policies are part of this role. This role is associated with my Lambda. So my Lambda will then be able to interact with these services. So now let's go ahead and cover the Python code that we're going to use in our Lambda function. The Python code is fairly simple. I've created an internal function to generate the audio file. The first thing it does is it calls synthesize speech, which is an AWS service, and we pass in the raw text. We pass in text type, which is in this case text. I'll talk about that more a little bit later. We also specify that we want the output to be an MP3 file and that we want to use the voice ID of Matthew, which is one of the voices supported for US English. Now, once we call that, we'll get back a stream, an audio stream, and we'll store that data in S3. And once it's up in S3, we'll be able to download it and to listen to it. Now, the raw text that I send is leave it better than you found it. So let's just go ahead and we'll run this Lambda, and we'll see that it's successful. And now we know that there should be an audio file up on Amazon S3. So we go look at that bucket, and sure enough, we have an audio file there. So now we'll want to download that audio file to your local system. And once you have it downloaded, you can play it with any of your favorite audio players.
Leave it better than you found it.
Okay, so you can see that we've generated audio from our text file, and it works nicely. Now, let's go ahead and go a little further. I wanted just to point out that there's a variety of languages that are supported by Amazon Polly. You can see them here. Within each language, there may be one voice ID or multiple voice IDs. In the case of US English, there's quite a number of different voice IDs. Some are male, some are female, some are adults, some are children, but you have quite a number, and this list is growing all the time. There's another really important feature that Amazon Polly supports, and it's the ability to provide it as an input SSML text versus raw text. And so, as I mentioned earlier, SSML is a markup language that allows you to add additional information to the text to to allow to to allow you to control pausing and emphasis and pronunciation. So now I want to show you an enhancement I've made to the Python code where we show an example using SSML. I have added a second internal Python function. Again, the first one will generate audio using raw text. The second one will generate audio using an SSML markup language set of text. First one we call, and we want to generate an audio file for leave it better than you found it. And now the second audio file that we're going to create, where we use SSML, I'm going to pass in the text. If everyone does a little bit, pause, it adds up to a lot. And so now, if I run this Lambda function, we can see that it's successful. And so now we'll go over to the S3 bucket. And indeed, we see that we have two audio files. Again, the first one we created just right now with the raw text, and the second one with SSML markup language text. And so now you want to download both of these audio files to your local system. And then once you've downloaded them, you can run them with an audio player. And we'll listen to the first one.
Leave it better than you found it.
Okay, so that's the version with the raw text. It was very simple. We'll go ahead and listen to the second audio file.
If everyone does a little bit, it adds up to a lot.
And so now you can hear the pause that was introduced using the markup language. So again, this is a really, really simple example of what you can do with SSML. There's much more you can do with it. I just touched the surface on this. Again, pauses, emphasis, pronunciation, it's quite powerful. If you want to find this code, you can find it on GitHub. I'll have a reference to the URL in the YouTube description. Now for some best practices. I would definitely use SSML versus just raw text because you have so much more control over the audio output. If you really want to do something with high quality, I strongly recommend using SSML. Now, if you have large text blocks, you're not going to really be able to use the exact same API call I made to synthesize speech. You're going to have to use the asynchronous speech synthesis APIs that are available. And so just know that when you get into larger text blocks, you're going to have to call that Amazon Poly service a little bit differently. But you can do that. So thank you for watching. All of the videos referenced in this video you can find in the YouTube description, as well as the GitHub URL to the code. I invite you to browse my channel and look for any other videos that seem interesting, and I encourage you to watch. If you like the way I'm packaging up this content, please consider subscribing. I would definitely appreciate that. And one last thing. We're all excited about AWS Cloud and all the innovation with machine learning and AI. But don't forget to carve some time to live in the real world. Get outside, go ride a bike, go swimming, go hiking, go move your body, and stay healthy. And with that, I'll let you go. Have a good day.